Hello friends, welcome back to Learn with Ansh. My name is Ansh and in this video we are going to be discussing about laws of exponents. So let's get started. So what are exponents? If we don't know about this, how are we supposed to know about laws of exponents? So let's discuss about this first. So let's take a number x. This can take any value, right? Now let's say we are multiplying this by itself. Well, this is a short expression, so we can write it as x times x. But what if we have many x's, or more of them, or even more of them? How are we supposed to multiply these? Well, thankfully we have a shorter way. We can represent this in the form of x to the power of n. Here, n is the number of times x is being multiplied by itself. Here, x is the base. It is basically the number which is being multiplied by itself. And n, as we already discussed, is the number of times x is being multiplied by itself. It is also known as the index or power or exponent. Now coming to our original example, x times x. How are we supposed to represent this in the form of x to the power of n? Well, since there are two x's, we'll write this as x to the power of 2 or x raised to the power of 2 or x square. Now why do we even need exponents? We need exponents to represent really huge values like the diameter of the earth, or really small values like the size of a cell. And I'm not talking about battery cells here. What I mean by cell is the biological cell. Now coming to the laws of exponents. Now if you Google it up or look it up in the math textbook, you'll find a huge set of laws like these. These are basically the laws of exponents. They may seem overwhelming at once, but don't worry, we'll look at them one by one. We are going to look at a few of these laws as a set. Now, let's look at the first set of laws. X to the power of 1 is equal to x. That's the first law in our list. Okay? Now, we know x to the power of 2 is x times x. X to the power of 3 is x times x times x. But what is x to the power of 1? It's just x, right? If we expand x to the power of 2 and x to the power of 3, we have 2x's and 3x's respectively. But in x to the power of 1, it's just x, right? So we've got this law clear, right? So that's basically what this law is telling us. Coming to our next law, x to the power of 0 equals 1. Now this law, you can just remember it blindly for now. We'll look at how this law has been derived later on. Now here we have the expanded form of x to the power of 2 and 3 along with x to the power of 1 and x to the power of 0. So x to the power of 0 is 1, x to the power of 1 is x, x to the power of 2 is x times x, x to the power of 3 is x times x times x. Here we have got positive integers cleared, right? But exponents can also take the value of negative integers. So how are we supposed to multiply x by itself negative number of times? Thankfully, our next law has got us covered. X to the power of negative n is equal to 1 over x to the power of positive n. That's our next law. So if we use the law, this is what we'll get. X to the power of negative 3 is 1 over x cubed, x to the power of negative 2 is 1 over x squared, x to the power of negative 1 is 1 over x to the power of 1 or 1 over x, and x to the power of 0 again it's just 1, right? So again, this law, just blindly remember it for now. We'll discuss how this law is true later on, because we need to know a few more laws in order to understand how this law and how the previous law is true. Now our next law in our list is x to the power of m whole to the power of n is equal to x to the power of m times n. Now let's take an example to understand this. X to the power of 3 whole raised to the power of 2 is equal to x to the power of 2 times 3. This is what we get according to our law. Now if we simplify this, we'll get x to the power of 6. Now let's expand this. X cube raised to the power of 2 is basically x times x times x times x times x times x. And this can be simplified to x times x times x times x times x times x, which is basically 6x's being multiplied together. And what does this mean? X to the power of 6. And that is our answer. So this law is true. Now coming to our next set of laws, x to the power of m times x to the power of n equals x to the power of m plus n is the first one in the list. Now let's take an example for this law. X to the power of 3 times x to the power of 2 is equal to x to the power of 3 plus 2. This is what we get according to our law. And when we simplify it, we'll get x to the power of 5. That's pretty obvious because 3 plus 2 equals 5. Now let's expand this x cubed times x squared. We'll get x times x times x times x times x. Now when we remove the brackets, we'll get 5x's being multiplied together, which is x to the power of 5. And that is our answer. Coming to our next law, x to the power of m divided by x to the power of n is equal to x to the power of m minus n. Let's take an example for this. X to the power of 7 over x to the power of 4 is equal to x to the power of 7 minus 4. Here I've written the division in fractional form. So according to our law, we'll get x to the power of 3 or x cubed as the answer. Now let's simplify it. So we'll get x times x times x 7 times and x times x times x 4 times. This is the expanded form of our question. Now we can cancel out the common factors, which is basically 4x's. So at the bottom we have nothing left, which is 1. And at the top we have 3x's left. So we'll get x times x times x, which is x cubed. And that is our answer. Now what if we have x to the power of 4 over x to the power of 7? What will be the answer? Well, we know that 4 minus 7 will be negative 3. So our answer will be x to the power of negative 3, right? So let's see how this is true. Let's expand this. So we'll get x times x times x times x over x times x times x 7 times. Now again, when we cancel out the common factors, we'll get 1 over x times x, which is 1 over x cubed. Hang on, that's strange. We got different answers. But hang on, remember one of the previous laws which we learned, x to the power of negative n? X to the power of negative n is equal to 1 over x to the power of positive n. And that is what we got. X to the power of negative 3 is equal to 1 over x to the power of positive 3. So now we know that x to the power of negative n is indeed equal to 1 over x to the power of positive n. Let's take another example for this one. X to the power of n over x to the power of n. Now according to our law, we'll get x to the power of 0, right? Now x to the power of n over x to the power of n is nothing but a over a, right? Which is basically same number over same number, which equals 1, right? So this proves that x to the power of 0 equals 1. Okay, now we have 2 more laws to go, and we'll look at these 2 laws as a set. Let's take an example for these laws. xy whole square is our example, and according to our law it will be x square times y square. And for the second law, we'll take x divided by y square, and according to our law it will be x square divided by y square. Now we expand our question, we'll get x times y times x times y, and for the second one we'll get x divided by y times x divided by y. Now we can rewrite this as x times y times y for the first one, and for the second one x times x divided by y times y. Now x times x can be written as x square and y times y can be written as y square. And there you go, these two laws hold true as well. And that's it for today's video. So thank you so much for watching, and I'll see you in my next one.